开始。The next page, please. Okay, the topic of our talk is about the simulation of the CPU scheduling the job. The scene in the assignment 2 is a simulation of the CPU scheduled job. The Y computer need the CPU scheduled job. A system will process the multiple requests at C time, but it's the results at the priority. And scheduling is the method used the corporation the use of the results for each request. Their concept is scheduling the priority, the time slice and the deadline, and CPU task scheduling is the responsible is for the scheduling the executable task to use the CPU. The I/O scheduling is for the order in which I/O request shouldn't seat the storage device, and the memory management is also kind of scheduling. The memory management maps the virtual memory to the physical memory. The physical memory is limited to the resource. When the virtual memory to be used to extend the physical memory, the capacity, the paging the maximum is to the scheduled which part of the physical page can be left in the memory and what is the content of the remaining and the physical page back to the desk, and the reduce this the remaining physical page. The next part, please.
There are many ways to manage tasks such as the first come first service, priority scheduling, fair share scheduling, and so on. In the assignment, we choose multi-level queue in priority scheduling to solve the problem. In a multi-level queue, each task is assigned the priority. Each priority corresponds to a queue, and tasks are stored in the corresponding queue. If tasks with different priorities are ready at the same time, the scheduler should process the tasks with the highest priority first. From tasks in the same priority queue, there is no uniform standard from the internet scheduling method. You can use different scheduling methods from different queues, such as first come, first served. Next, we will introduce the implementation detail.
Yeah, okay, I will cover more in-depth information for MLQ and how do we achieve it. So as you can see the graph, specifically our group defined two queens, high queue and low queue. While high queue represents for customers with high property and low queue represents for regular customers. So additionally, we add an equal probability mechanism for superflag, and also add a self-defined mechanism that is when the low queue is greater than 8 and high queue is greater than 10, the program will check if there are any customer in the queue who has never played in the machine. So if there are anyone, it will obtain a property execution in its queue. So this mechanism is to prevent customers for waiting too long when the queue is too long. At the end, the program will check if there are anyone waiting in its queue respectively. So that's it.
So in a conclusion, this assignment effectively solves the problem, thus providing the effectiveness of LMQ. However, there is a disadvantage in this strategy. That is, lower priority tasks sometimes may be hungry. If the scheduler needs to ensure a certain degree of fairness, additional mechanisms need to be introduced to mandatory the test waiting time, so as to increase the priority of tests with too long waiting time, such as excluding a center shareholder. So that is our video. Thank you for your listening.